All right. Hi, guys. It's 8 o'clock, so we're going to give everybody another maybe 30 seconds to a minute to get on, and then we'll get started. If you're not in my class and you would like to interact live, you've got two options. So option one is that you can just type in the YouTube chat. You have to be logged into your YouTube account to do that. So if you have a YouTube account, great. If you don't want to do that, that's fine. Option two, at any time, you guys can send me a remind. So you are totally welcome to do that at any point. We are going to go through your review sheet tonight. I'm going to try to highlight some major things that you would want to know, and your test is going to be tomorrow. So, a couple things before we get started as people are still logging on. Tomorrow, it's important that you come with your calculator, charged, okay, a compass. Even if you borrow it from a friend, make sure you have one. If you need to tighten the screw in there, do that tonight so it doesn't slip all around, and bring your ruler. All of these are things that you're going to want for the test tomorrow. If you are in my first or third block, you're taking the full test. If you're in my fourth block, you're going to take part of the test, and we're going to do the second part on Friday. So you'll be kind of splitting it up over 2 days just because you have a shortened block. But you're not going to get any additional advantages. You won't see the test. It'll be a different part that you take on the second day. Okay? So we're going to give everybody another minute to get on. Hi to everybody that's on already. And again, you can either interact with me on Remind. If you're not in my class, use the link that's on your screen right now, right there, and you can sign up. And if you'd like to just use the YouTube chat, feel free to do that. I don't get any of your information. It just says your name. Okay? All right. Well, we're going to get started. If people log in halfway, that's fine. You are never interrupting me if you send a question, okay? If you send a question. So, yeah, it says, will I be there tomorrow or is there a sub? There is a sub. I will not be there. I'll be there in the morning early until about 7:20. If you have questions, feel free to come then. But I will have a sub for the day because I'm out at a meeting all day. I will still be at a meeting, so I will still be on Remind. You can bother me all day with questions. But I will not be there for actual class. Okay, so this was your review sheet. And on here, something that I did on this one was I not only put questions, but I also put the topics. So you're going to see on here what topics that I really need you to know. If there's something that you're struggling with, look at what that topic is called and go back to that, okay? So on the first one, this is talking about angle relationships. And we're talking about the measure of the exterior angle. So this is called the exterior angle theorem. And it says that if I have a triangle, this exterior angle is going to be the same as the sum of the two interior angles that are non-adjacent to it. We call those remote. Remember, I drew like a little remote desert island. So let's say I was looking at this first question. Well, it's indicated find x. So this is my exterior angle, and that's going to be equal to the sum of my two interior angles. So sum should signal to you to add. So this would be 2x plus 103 minus x equals 6x minus 7. Okay, that's what the exterior angle theorem says. So now what I'm going to do is I'm just going to solve that. So it doesn't want to let me zoom. That is okay. 2x plus 1x is just, or minus 1x is just x, plus 103 equals 6x minus 7. I'm going to subtract x from both sides. So 103 equals 5x minus 7. And add 7 to both sides. So 110 equals 5x. So get x alone, divide both sides by 5, so x here would come out to be 22. Okay, again, if you have questions along the way, just send them. But that's what the exterior angle theorem says. The next one under the same topic, we want to determine the value of the obtuse angle given by x. So I'm going to start with what I know, and I'm literally going to ignore all of that stuff with x. I'm just going to look here. I see that these create some linear pairs. So let me figure out what I know. If this is 85, this has to be 95 because those need to add up to be 180. Okay? If this one is 127, This would have to be 53 because, again, linear pairs have to add up to be 180. And you could fill in all the angles around here. These are vertical angles. These are vertical angles. Again, lots of information there. Some of it's useful, some of it's not. Here's the key to this one. We need to see that right here, let me make that a little smaller. Right here, we have a triangle, right? Right here we have a triangle. And the angle sum of any triangle has to be 180. So if I have 53 and 95, okay, 53 plus 95, those have an angle sum, those two, of 148. So if I do 180 minus 148, which is 95 plus 53, I get 180 minus 148, and that gives me that this angle is 32. If that's 32, since these form a linear pair, this also has to be 148. And you could have skipped a step there. You could have said, this is my exterior angle. These two are the non-adjacent interior angles, and so that would also be how I know that that has to be 148. But a lot of the times on these, you can check yourself, okay? So that is what the exterior angle theorem says. If you have questions about that, send them, okay? You're never interrupting, just send them. Until I see some questions on these, though, I'm going to keep going on, and we can always come back, okay? Next one, the side relationships. So this is the triangle inequality. And this is when we talked about that the length of one side has to be less than the sum of the other two sides. So remember when we did the pasta activity, we said A has to be less than B plus C, B has to be less than A plus C, and C has to be less than A plus B. So we set up an inequality with every possibility, right? So what I'm going to do on these is use that idea. What value of x would allow the sides to form a triangle? You could try every pair and see what works, but here's what I would do. I would say, let's set up some inequalities here. So my sides here are 8, 20, and I don't know the third side, so I'm going to call that x. So over here, I'm going to set this up, 8, 20, and x. So my inequalities, add the first two, that has to be greater than x, right? Add another combo, that has to be greater than the third one. Add another combo, that has to be greater than the third one. And I'm going to solve each of these for x. So on this first one, I would have 28 is less than x, or is greater than x. Here I would have x is greater than 12. And here I would have x is greater than negative 12. This one is fine. It's not wrong. But on that, what I see is that it tells me that my side length needs to be positive, which it should. So I know now that this is my smallest number and this is my biggest number. So the inequality I get here is that x is less than 28 but more than 12. So what I'm going to look at is which of these fit that. This is less, or this is equal to 8. Not good. This is equal to 12. Not good. This is equal to 28. Not good. So it has to be C, because that's the only one that's in that interval. And we also talked about a shortcut to do that. We also said that to get that the range, you could add your two side lengths, and you could subtract your two side lengths, right? And that should be an 8. And so now I know my range would be between 12 and 28. Again, just another method to do that. But the inequalities always work. So I would say go with those if you need it. Okay? All right, the next one. What are all possible lengths of the third sides if the two sides you know are 14 and 12? So I know 14, I know 12, and the one I don't know is x. So again, you can just add them together and subtract them, but let's say you wanted to do it with the inequalities. So here's what I would do. I would say 14 plus 12 has to be greater than x. I would say 14 plus x has to be greater than 12. And I would say 12 plus x has to be greater than 14. And I'm going to solve each of those for x. So this first one is 26 is greater than x. The next one tells me x is greater than negative 2. I hope so. It's a side length. And this one tells me x is greater than positive 2. So my range of sides would be between this one and this one. So I'm going to put my smallest one here, put my biggest one there, and write my inequality x's between those. Okay? So good question. What do I mean when it says that I can just add the side lengths or subtract them? So if you don't want to set up all the inequalities, what we said was that here I got 2 and 26, right? If I take the two sides I already know and I add those up, think about what I get. 14 plus 12 is 26. If I subtract them, 14 minus 12 is 2. So it's just another way to get these two values. If you don't want to set up every inequality, you can just add the two segments or two lengths you know and subtract the two lengths you know, and that will give you your biggest and your smallest. Continue to send questions. I love them. Okay. So these next ones are talking about joining the midpoints. So these are called mid-segments, right? They're going to be parallel to the third side and half of the length. So if I have something that joins the mid-segments of my sides, it's parallel to the third side and it's half of that length. So if I look at this one right here, Jason's measuring the distance across the pond. What is the distance from A to B? I want this distance, right? So I see that each of these, A and B, are midpoints because this is congruent to this is congruent to that, and that means that this is a midsegment. So what I know is that this will have to be half of the side it's parallel to, and it's parallel to the 630. So half of 630, this would be 315 feet. Okay, midsegment, half the length. Let's take a look at this one as well. So D, E, and F are midpoints. As soon as I see midpoints and I see these parallel sides, I'm thinking half the length, midsegments, right? So I'm going to look at the ones with the same variables first because these two have different variables and I don't want to deal with that right now. So this side is parallel to this side. Okay, those two sides are parallel. And so that means that this is half the length of this. So there's two different ways you could set this up. You could say that x is half of 4x minus 18. Distribute that one half out. So that would be x equals 2x minus 9, and then solve. Or I could say, well, to get AB, you would have to double this, right? So I could also say 2x equals 4x minus 18. They're exactly the same equation. It doesn't matter which one you use, okay? Exactly the same. So solving either one of these doesn't matter. I'm going to get x equals 9. So that's my x value. Okay. From there, now I want to get my y value. So here's what I know. I know x is 9. So BC over here, I could say that's 2 times 9 minus 4. That's 18 minus 4, so this is 14. So this length of y, knowing that these are parallel, and they should be exactly parallel, knowing that those are parallel, would tell me that this has to be 7, because it's half of that length. So x is 9, y is 7. Carolina, I see your question, but can you tell me what you're talking about there? Which question, which part? I'm not quite sure what you mean by that. Just elaborate a little more, and then we can come back to it. Okay, so these are the basics with segments and angles that you need to know. We're going to move on to the centers of triangles now, which is kind of our second major topic. Again, send questions as you have them. I want to answer them. Send away, okay? All right, so the next part are these centers. All right, before we go on to that, I'm going to go back to Caroline's question because she was getting a little bit more specific. So she said, how did I get 630? So, okay, these are the sides that are parallel, this one and this one. So 630 comes from right here. It has to be half of that length. I agree if we use the other side, it would be 540, but always use the one it's parallel to. Okay, Your constructions. You need to know your centers. Okay, I guarantee you will have constructions tomorrow. Some may just be segments. Some may be constructing the centers. So here's what we need this to be, okay? When I see in center, I need automatically to think angle bisector. Automatically. That's what I want to see. And so to construct an angle bisector, you would draw an arc. And again, I can't use my compass on my iPad. That's what I'm using. So you would do this with your compass. You would use these two as your endpoints. Draw an arc from one side, other, and then that would be your angle bisector. Then pick another angle and do the same thing. Draw an arc, do an arc from one side, an arc from the other, right? Arc here, arc there. Draw in your angle bisector. That point right there would be your in center, okay? That point right there would be your in center. Again, mine's probably not exact because I didn't use a compass, but angle bisectors. Okay, the next one, the circumcenter. Circumcenter is always going to be a perp bisector. Perp bisector. So all that is a bisection, right? I'm going to take this, open my compass more than halfway, do an arc above my segment and below, move it to the other endpoint, do an arc above and below, and draw your bisector through there. I know mine's not perfect. I didn't have a compass. Okay? Same thing over here. So I'm going to open it more than halfway, do an arc above and an arc below, move to the other side, arc above, arc below, draw in your perpendicular. Don't panic if they don't cross. All that means is you need to extend one out further. And this would be your circumcenter. Now it says, construct the inscribed or the circumscribed circles. So if I'm doing a circumcenter, I'm going to put my compass on the circumcenter, measure to any one of the vertices, and you should get a circle that goes exactly through all of the vertices. Mine is not going to be perfect because, again, I don't have a compass, but that's what it should look like. Okay? And in center, we would need to construct a perpendicular from this point. Construct a perpendicular, measure from the in center to that point, and then you could construct your circle there. Okay? All right, continue to send questions. We're just going through the constructions. All right, number 9, the orthocenter. Think about ortho, think about al. Al is going to the orthodontist, so this is altitude, right? So, altitude, I'm going to, from a point, open it, my compass just past the opposite side, draw an arc that crosses both sides, or crosses that side twice, sorry. And then from there, from those 2 points, do your arcs below, and that should be perpendicular. Then you're going to pick another side, okay? Then you're going to pick another side. So let's say I go from C. This doesn't extend all the way out, so I might need to extend this out further, okay? I'm going to put this just below the line and draw an arc. From those 2 points, I'm going to do an arc below from both points, and then draw in your perp. Again, this may not cross. That's fine. Just extend your lines out until they do, and that would be your orthocenter. Okay, I did just see a good remind question. Let's see what it said. It said, how do you find the circle in the circumcenter? All right, I'm going to go back to that one. So let's say you found your circumcenter here. I'm going to actually just erase my circle. You're going to put your compass on the circumcenter, put your compass on a point, and then measuring your compass would look like this from there to there. Obviously, you don't want that mark. That's my compass. Pretend that's this. Okay? You're going to just draw a circle that should go all the way around. Yours would actually be a circle because you're using a compass. That's all you need to do. All right, last one, centroid. Centroid, well, Al went to the orthodontist and his medicine only cost a cent, right? So that's a median. So medians, you're going to construct the perp bisector, but you're only going to mark where the midpoint is. and then you're going to connect from there to the midpoint. That's your first median. Then you're going to do the same thing for another side. That's your midpoint. And then you're going to connect to the opposite vertex. So that would be your centroid. And we're going to talk a little bit more about centroids in a minute, because remember, centroids get divided in a ratio of 2 to 1. That I just wrote a 2 to 1. So 2 parts and then 1 part. Okay. That's all we're going to talk about for constructions right now until I see some questions, okay? So please, if you have questions, send them. We're going to talk about this one now, the centroid thing. And if you're in my third block, you guys are going to have a warm-up. That's a little more practice on this. And I am going to have a video going over it so that you guys can get a little more practice, because I know we got cut off by the bell at the end of class. So the centroid divides the median in a ratio of 2 to 1. So anytime I see that, here's what I'm thinking. I'm thinking, okay, I know that this is a centroid. That's my median, right? I'm going to think about this as being 2 pieces up here, and then 1 piece down here. So a couple important things there that you might want to think about. First of all, that means that there are, if we have 2 pieces here and 1 there, that there are 3 total pieces, right? So if I give you the whole length and you want to find a part of it, you might just want to divide by 3, and that would give you a part, okay? Also, if this is 1 part and that's 2 parts, to get the top, you could just double it. So we did it with proportions, but you could also do it this way. We talked about that other way to do it, right? So let's say I look at this. I know that this is a centroid because each of these are medians. So what I know is that this is divided in a ratio of 2 to 1. So which of these is true? Well, are those angles congruent? I don't know. They're not angle bisectors. Don't know. Are these congruent? Don't know. JZ is congruent to JX. It might look like they are, but we don't have any indication that that's true. So it's not this one. So let's talk about why it's this. Why it's this. It's this because this is 1 part, right? And this is 2 parts. So to get that, you would have to multiply by 2. And actually, we were talking about these segments, but same idea, right? Okay, before we do one like number 2, I want to just do a simpler one. I'm just going to draw over here. So let's do one more like this. Let's say that I tell you that's the centroid, right? And I want to know, maybe I tell you this is 12. I want to know how long this is, and I want to know how long this whole length is. Okay? So here's what I would think about. I would think about that this is divided in a ratio of 2 to 1. So 1 part is 12. So these 2 parts would have to be 24, twice as big. So how long would the whole thing be? Well, that's 24, that's 12, so the whole thing would be 36. Okay, so let's do one more. The length of PT, if PV is 3x minus 1, and VT is x plus 2. So, where I'm going to assume that this is in a triangle where the centroid is V, because that was not adequately labeled. So they tell me that PV is 3x minus 1, and VT is x plus 2. So think about what you know about this. This is divided in a ratio of 2 to 1. So to get from this to this, you would need to double it. So I'm going to double the smaller part, and that should give me the bigger part. It's just like a midsegment, right? So 2x plus 2, or plus 4, excuse me, equals 3x minus 1, and that would give me x equals 5. So if I want the length of PT, I need to plug this back in. So this piece would be 7. This piece would be 14. So that means PT equals 21. If you have more questions about centroids, send them. I am happy to do more. Until I see more questions, we are going to skip ahead. There's only one centroid question on the test. It's not a huge topic, so just make sure if you have questions, ask them. Okay? All right. So now we're going to talk about this. This is a pretty major topic. We spent a lot of time on this. This is something that's important. So the two things I want you to think about are this. I'm going to draw my two little triangles here. There's one. There's the other. On your quizzes, these were great. So go back and look at your quizzes if you need to. So on this one, this is my altitude, right? And if I highlight my altitude, the other two parts I'm going to look at are that and that. On this one, this is my leg. And if I highlight my leg, the other two pieces I'm looking at are this piece closest to that leg and the whole thing. And remember, when we set this up, it's always going to be a proportion where we have those on the other side, right? Those opposite each other. And then the one that's its own color is going to repeat, right? It's going to have to repeat. So let's set these up and see how. The first one, I want to find X, right? So when I color code these, that's its own color. And then these two pieces are another color. So this is going to be X and X, that should repeat, and 3 and 9. So I get X squared equals 27. Square root both sides, X equals the square root of 27. And unless they tell you to simplify, don't, okay? Unless they tell you that you need to round, don't. Just leave it. All right. Next one, I want to find the altitude, right? I want to find the altitude. And I know that, actually, let's skip this one for a second. Let's come back to this one. Let's look at this one. So I want to find my altitude, I know my altitude. And when I highlight the altitude, this and this are your other two pieces, okay? So this piece I know is 7. If the whole thing is m, then this would have to be m minus 7 because I'm taking away that part that I already know, right? The whole thing's m, take away the part you know. So now I'm going to set this up. My proportion is going to be 5 repeating, right? And then 7 and m minus 7. So cross multiply, I would get 25 equals 7m minus 49. Add 49 to both sides, so I would get 74 equals 7m. So m is 74 over 7. That does not simplify. That is okay. Again, unless they tell you that you need to round to a certain place, you don't necessarily need to. This is irrational, or not irrational, but it's not like rounded to a nice number. So just leave it like that. All right, let's look at, how about 29? 29, okay? So I gotta find X, Y, and Z. Don't let this overwhelm you. Do one at a time. I'm gonna start with X. So there's my altitude. And I see this piece and that piece. And those look like the same color on my screen. This piece and that piece. So when I solve this, the 32 should repeat. And then this would be X and 24. So I would get 24X equals 32 times 32, which is 1024. Divide by 24. And so you actually get a repeating decimal. You get 42.6 repeating, which you could also just leave as 1024 over 24. Okay, I had a question on the last one. For 27, could you put it in decimal form? Let me look at what the decimal form looks like. So the decimal form is 74 over 7, which is 10.5714286. That's what my calculator is showing me. You could, if you copy it all the way out, but I would say unless they tell you what to round to, just don't round it, okay? So if you do, don't round it to 10.6. That would be wrong. You only want to round in the case where you are told to. All right, let's say I want to do another one. So to find y or z, you could do the right triangle, all the proportion stuff. But if I know this, I know two sides of a right triangle. So for instance, on this one, notice that this is a right triangle, right? So y is my hypotenuse. So I could say 24 squared plus 32 squared equals y squared. And let me get those really quick. 24 squared is 576. 32 squared, I believe we said before, was 1024, is y squared. So together, those are 1600 exactly. Square root both sides, and that gives me that y is 40. So that's 40. Then, if you know these other sides, you could do the same thing. So you could say, okay, use Pythagorean theorem on this. I know that this side is 1024 over 24. And you could do this side squared plus this side squared equals that side squared. Okay, so just take it one side at a time. All right, there's one last one of these that I want to do. One last one, and that's 30. Okay, the key is on my website, so if you want to look at the other ones, just go look at my website. The key will be up there. But I want to look at this one because look at what happens here. I get this, and I get that, right? So what I wind up with is x plus 9 in both places, repeating, 8 and 18. So the setup, the geometry of it isn't that bad. But then we need to cross multiply. So I get x plus 9 times x plus 9 equals, and let me just calculate that really quick, 18 times 8 is 144. Notice I have a binomial times a binomial. So what I'm going to get here is a quadratic equation. I'm going to need to multiply these two things together using either distribution, double distribution, or the box method, whatever you prefer. This is going to be x squared plus 9x, which is 18x, plus 9, which is times 9, which is 81. And this is, I see an x squared, it's quadratic. So I'm going to set this equal to 0. So I'm going to subtract the 144 over, so minus 63. Now we need to factor this. So I need to find two numbers that add to be the middle, multiply to be the end. Okay? And I'm just going to divide. So 1 times 63, or 1 times 63 is 63. 63 is not divisible by 2. 63 is divisible by 3. It would be 3 and 21. Okay? And so that would give me x, 3 and 21. So negative 63 would be positive 21 and negative 3. So this would give me x squared. It would give me x plus 21, x minus 3 equals 0. Then I'm going to set each of those equal to 0. This gives me x equals negative 21 and x equals 3. I can't have a negative altitude length, right? So this would be my solution. Now somebody said, why can't you just square root it? You cannot square root something like this. Here's why. Let's say I did this and I got the x squared alone. So x squared would equal 63 minus 18x. If I square root both sides, do you notice you still have an x over here? So x, it really isn't alone. So anytime you have an x squared, you want to try to set it equal to 0 to solve it. Okay, that's obviously a more difficult type, but that is another type that could show up. It could be a bonus. You should be able to solve a quadratic. Okay, so let's go to the last part. So write a similarity statement for the three triangles shown. So we've got a small triangle, we've got a medium triangle, and we've got a big triangle. And remember when we took these and we cut them apart, right? So in the small triangle, that would be triangle, I'm going to name this B, D, C. So I just took this and I spun it and kind of lined it up there, right? Okay. The next one I'm going to look at is this medium size one, which if I line it up would be C, D, A. There's my right angle. And then the big one, if I just kind of flip it over, it would be B, C, A. So, my similarity statements, you should have triangle, and they should go in corresponding order. B, D, C, so I went from B to D to C. So the next one should go C, D, A. The next one should go B, C, A. Okay. Now, why using angle must these be similar? Well, all of these have a right angle. So that's one angle already that they all share. Then we're going to look for some reflexive property. So notice this. In your little triangle, in your big triangle, they both overlap at angle B. Okay? And in your medium triangle, in your big triangle, they both overlap at angle A. And so those are my two pairs of congruent angles. So I have two pairs of congruent angles. By angle, those triangles are similar. All right, now I want to describe transformations that would map BDC, so that's my small triangle, onto CDA, that's my medium triangle. So I'm actually going to zoom in and look at this. So here are these, right? This is my triangle. I want to map those. So what I'm going to do is I'm actually going to say, okay, this is my long leg, right? So's that. So I am going to rotate this to map that onto there. So that's my first move. So I would rotate the triangle to map onto that. So first thing I would rotate clockwise, and I'm rotating triangle BDC clockwise, okay, about point D. 90 degrees. And there's no mapping here, right? When I actually do that, point C would map to somewhere right there. So there's no mapping that happens. And then I would need to dilate it, right? So then I would need to dilate from D, that's my center, out, right? So I would dilate that out from this length to this length. Okay, so somebody just said, will this be on the test? This is a good review of what we've done before. It shows why they're similar. There's not a question like that specifically on the test. Okay, last thing, and then I just want to leave time for questions because we've got about 15-20 minutes left. Finding these centers, okay, finding these centers. All right, so let's find these centers. So in each of these problems, name the point of concurrency. So you need to know your points of concurrency. So let's look at the first one. I see that each of these angles is being cut in half. So these are angle bisectors, which tells me that this is an incenter. So that's how I know. And you could draw your inscribed circle in there. The next one, I see that these are perpendicular and that these are being cut in half. So these are perp bisectors. And that makes the circumcenter. Okay. The next one, all of these look like heights of the triangle. These are altitudes, right? They're just perpendicular. They're not bisecting. So these are altitudes, okay? Altitudes go to the orthocenter. Al goes to the orthodontist, right? The next one, these are perp bisectors again. So same as before, these are perp bisectors. And these make the circumcenter. Okay, this one, notice that's the inscribed circle, which means I know that this is the incenter. And the incenter, what is that? Made by the angle bisectors. Last one, I see that this is a circumscribed circle. So I know that this is the circumcenter. And if it's a circumcenter, that is made by the perp bisectors. You need to be able to match those up, okay? Okay. That's finding missing angles. We're going to look at 14. This is the angle bisector theorem. So, we're going to come back to this because somebody just asked a good question. So they said, how do you tell a perp bisector from an altitude? So let's say I have this, right? And all I have is that marking. All I know there is that that's perpendicular. I don't know that it's a bisector. Versus if I have, sure, we'll do that. If I have this and I see that it's perp and those are being bisected, right? Those are marked congruent. That's how I know it's a bisector. So this is an altitude, and this is a perp bisector. If it's a bisector, you need some indication that those are midpoints. Okay, so here's what we did with these. Remember, we would kind of like draw triangles going like that, or arrows, and we would divide those. Okay, so I need to know my length. So I know this one is x and that one's 8. So I would do x over 8. This one is BD. I don't know what that is right now, but that's 10. So it's going to be something over 10. So I need to figure out what that is. So if my entire length is 12, then this would be 12 minus x. Because again, your whole length is 12. Subtract out the part you know. So 12 minus x. And then cross multiply. 10x equals, this would be minus 8x. And really quick, because I can't do that in my head this late at night. 8 times 12 is 96. Add the 8x over, so that's 18x is 96. And divide both sides by 18, which is 5.3 repeating. And feel free to leave it as a fraction. Okay. So that's what I had as priorities for right now. Again, the key is on my website. You guys can find it there. But what else do we have questions about? I'm going to hang out for about 5 to 10 more minutes, see what you have questions about. Here's what I will tell you guys. If I were you, if I were studying, these would be my biggest priorities. Okay? Ready? My biggest priorities would be making sure you can find these kind of angles. Okay? Finding the triangle inequalities. Knowing your centers and your constructions. There again, I told you guys, is one centroid question. These are very important. Okay? The right triangles are very important. So make sure you know those. And there is an angle bisector. So make sure you know that. Okay? Those are my priorities. The other ones, some of these are more challenging. They're just meant to kind of make you think. But what else can I answer? I'm going to just sit here for a couple minutes, wait for you guys to answer. Nobody's going to know if you ask a question. I don't have to say your name. So just send it if you have it. Would a question be like number 15 be on the test? So 15 says, altitude AC is drawn in such a way that BC to DC is 4 to 1. Find the length of DC algebraically. So this would be a difficult one. But if it was 4 to 1, here's what I know. This would be 4x, and this would be 1x. Right? It's 4 times something and 1 times something. So if I set this up, the 12 would repeat, because this would be its own color. And then this would be another color. So x and 4x. So I would get 144 equals 4x squared. Divide both sides by 4. So doing that, I would get x squared equals, again, I can do this in my head, but it's late at night, 36. Square root both sides, so x would equal 6. So if I wanted DC, that would be my answer. So again, is that more difficult? Absolutely. But is it a concept we've learned? Yeah. What else? Ask away. This is a no judgment zone. Anything, anything, anything. Are you bringing your ruler? Are you bringing your compass? Are you bringing your calculator? Is your calculator charging? If you guys have more questions after I log off, you can still send them to me on Remind. Just take a picture, send it to me, okay? If you have questions tomorrow, send them to me. I'm going to be sitting in a meeting. I am happy to answer your questions during that meeting. Okay, this will be up on my website if you want to go back through anything. But for now, I'm going to sign out. I don't see any more questions. I think it's a very fair test. Again, look at the right triangles with the proportions. That is really something we spend a lot of time on. Make sure you know your centers. And otherwise, I really do think as long as you guys have studied, you'll be ready. I know we lost our review day because of the snow, but I think you're going to be ready, okay? So let me know if you have other questions, and I will see you guys. Yeah. Bye.